It's the substitution rule. And this is, I would say that to help you out with the rest of your calculus career, raise your hand if you're taking calculus next year. Calculus, raise your hand if you plan on taking calculus 1 next year. 1, 2, 3, 4, 5, 6, 7. Okay, probably about 10 of you. Raise your hand if you're planning on moving into calculus 2 next year. Okay, 1, 2, 3, 4. Okay, 5, 6. Okay. If you want to experience success in calculus 2, this skill that we're going to learn right now, it has to be absolutely perfected by you. Okay. What you're doing right now is substitution rule. They learned it very, very well last year. They learned it very well. At first, they were like, well, what's the big deal? We would do, kind of, this is just basic introductory stuff. And after this, you'd be like, well, you made a big deal about nothing. Well, okay. But then you get to step 2, and they're like, well, I could still do that. Step 3, they're like, okay, I can see that would be more difficult. And then I throw you a bunch of problems where you got to figure out whether you use step 1, step 2, or step 3. And you're like, okay, now I hate life. Well, now it is like your brother put a fish hook in the back of your neck and pulled it. Yeah, so exactly. There, Jacob. Or cousin, whatever. So, yeah, sorry for the fish. So anyway, that's where we're at. And I just need you to be patient with it, and I need you to just try to understand the concept, and we'll be good to go, okay? All right? I'm going to start out by doing a very, very, very basic problem. Everybody watch. Shh. Okay. Shh. X squared dx. Watch. Okay, you don't have to write this anywhere. You're going to totally get this. When I do that type of problem, I ask myself, what do I take the derivative of to get x squared? What do you take the derivative of to get x squared? X to the third over 3. Okay? All right? So we are constantly trying to think about what we take the derivative of to get something else. Okay? Now, let me change it. Okay? What if it was like this? Okay, yes, you could multiply it out and then no problem. All right? What about that? That you're not going to multiply out. Okay? No, just watch. Just watch, okay? When you take the derivative of this, you would use a chain rule, right? What's the derivative of the inside? 1. So you can see that when the derivative is 1, it really doesn't cause an issue. And in fact, the antiderivative of this is exactly x plus 5 to the 51st power divided by 51. Only because the derivative of the inside is 1. If we switch that and have the rate of change of the inside different, then that will affect things. So the substitution rule is a nice technique to use when you have kind of an inside piece. And we'll go to work. Here's how it works. What's my inside piece? True or false? If I took the derivative of 4 plus x to the third to the 4th power, I would end up with still a 4 plus x to the third somewhere there on the board. Yeah. And when you take the antiderivative, you would also end up with a 4 plus x to the third somewhere on the board. So what we need to account for is this issue right here. Okay? I'm now going to take the derivative of u. Okay? And I call that du. what is the derivative of 4 plus x to the third? No. Shh. Not the antiderivative. What is the... And we'll attach a dx to say that we took the derivative of it. Now watch what's going to happen. Do you see a 3x squared up in this problem? Yeah, do you see a dx up in this problem? So this right here, we account for it there. We account for it here. And we can replace that stuff with what? du. Now, look at this part. Do you see a 4 plus x to the third up in that problem? Right there. I can replace that with a u. So instead of doing this integral, which looks complicated, let's do this integral. The integral of, instead of a 4 plus x to the third, I put in a u. What power am I taking u to? The fourth. And instead of a 3x squared or a dx, I put a du. So that's the substitution principle. I can easily take the antiderivative of u to the fourth. What is the antiderivative of u to the fourth? U to the fifth over 5 plus c. Now that I've taken that antiderivative, what do you think I do? Just like in the chain rule, when you substituted something back in for u, you're going to substitute u back in, and you will get 4 plus x to the third to the fifth over 5 plus c. Watch. Oh, you asked excellent questions. This is a very good question. What about the 3x squared? If I wanted to verify that this is in fact correct, what could I do? Take the derivative. If you take the derivative of this and come up with that, that's what we just did when I wrote out problem 3. We verified that that was correct. So you could take the derivative. So let's do that, okay? If I take the derivative of this, I have to use what rule? The chain rule. What's the derivative of the inside? 3x squared. Do you see that up here? Oh, yeah. And then what I'll do is I'll take the derivative of the outside. I'll put the 5 in front, and that will cancel out with the 5, and it will reduce the 5 to 4. You see, it's reduced to 4, and I have the 4 plus x to the third. So if you ever want to check your answer, just go ahead and take the derivative, and there it is. And so now you've used the substitution rule. Now, we are just taking basic steps today, but we're going to now do a very similar one right here. Only it's going to be just slightly more complicated. Okay? That's the answer. That will be the easiest type of problem that you would have on your test right there. Okay? Okay, the next one. Identifying u is the biggest trick, okay? Now, you saw how it happened right away, but what do you think I say u is in this problem? 4x squared minus 3. Now, you might ask the question, well, how do I know that's correct? Well, for this problem, it's pretty easy to see. For this one right here, it might be a little bit more difficult to see. But I'll tell you one way to tell if you're correct. If I say u is 4x squared, what's the derivative of 4x squared? 8x. Do I have an x up here? Yeah. Do I have an 8? No. I can take care of constants very, very easily, and you'll see how it happens here. But what I can't take care of is, let's say there was an x squared in front of here. If there was an x squared in front of here, that would be a significantly more difficult type of problem. Significantly. Okay? So let's go to work. We say that u is equal to 4x squared minus 3. And now I take the derivative of both sides. The derivative of u is du. What's the derivative of 4x squared? 8x. Do you see an 8x up there? No. Let me show you a trick. Constants always just come along for the ride. They're just always a part of there, and if you want to, you can move things out. So watch. I'm going to rewrite this instead of 7x times 4x squared minus 3x to the third. I'm going to write it like this. 7 times the integral of x times 4x squared minus 3 to the third dx. You can do that. You can move a constant out front. Just like we did with our summation pieces, same rules apply. Okay? Oh, forgot my dx. Very important. Okay, so up in this problem, you now see that you have a 4x squared minus 3 there, right? Do you have a dx? Yes. Do you have an x? Do you have an 8? So you got to get rid of the 8. And here's what we do. We divide the 8 off, and we get 1/8 du is equal to x dx. So we remove constants just by solving for what we want to have. If we see an x dx up there, then I make sure I have an x dx. So let's make sure that all of our parts are accounted for. This x is right here. This dx is right here. My 4x squared minus 3 is right there. So I can replace that with a new integral. And the new integral is as follows. 7 times the integral of what? U to the third times 1/8 du. Does that 1/8 bother you? It should. Where should you move it? Just move it out front. So this would be the same as the integral of 7/8 u to the third du. So again, all I'm doing right now is just playing with the constants. Now I have an integral of u to the third. Is that easy? Yeah, that's easy. What's the antiderivative of u to the third? U to the fourth over 4 plus c. What can I do with this? Yes, question. See the 1/8? So here I had du is equal to 8x dx, but I didn't have an 8 up here. Here we were very fortunate. See, yeah, so look here. What's the derivative of x to the third? So it's that exact same thing. Oh yeah, that would be nice. But in this situation, I had a 4x squared. The derivative is 8x, but I had a 7x. So if the constant doesn't match perfectly, that's why we end up with 7/8. Yes. Okay. Now I can substitute u back in, and what I end up with is all the 7 on top times the quantity 4x squared minus 3 to the fourth over 32 plus c. Any questions how I got that? Okay. So how about we pause right now, because this will be a good spot. I'm just going to give you a problem, and I want you to see if you can find the antiderivative on your own. Yeah. Okay. Flip your sheet over. You got room to work on the back side. Antiderivatives. Yeah. There you go. 4x times parentheses x squared plus 5 to the 14th dx. See if you can do it. I'll pause the video. Okay, there's a couple ways to tackle this problem, none of which are incorrect. Well, there's probably some out there that are incorrect, but I'm not going to show you they're incorrect. You should first say that u is equal to x squared plus 5. And then when you do du, you get 2x dx. Now, here's the kind of short way of doing it, okay? Watch how quick this is. These don't match up, do they? So what do I have to do with the 2x to get it to be 4x? So now I can replace... No, watch. Okay, as you see here, I multiply both sides by 2. I get 2. So I can replace this 4x dx with 2 du. Now, a lot of you guys didn't do that. A lot of you guys did this, and that's fine. You rewrote it up here to be 4 integral x, x squared plus 5 to the 14th dx. And you said, okay, well, I'm going to divide by 2, and you get 1/2 du is equal to x dx. And so you said, okay, now I can make my substitution. So I've got 4. I've got, let's see, x squared plus 5. Whoop, I'm sorry, u. Got u to the 14th and times 1/2 du. What did you do with that 1/2? 2 is out front. Well, I had the 2 right away, right? That's what the 2 was. Because it doesn't work every time. I can't, yeah, it doesn't matter. I'll tell you what. The way I first did it, where I put the 2 du out front, I do it that way every stinking time. But I never would have tried that with this problem in fear that I'd make an error. Because, it's like, oh, well, I got to get, let's see, I've got to get a 7 out front there, but I've got an 8. So how does that work? Okay, you can you can try to take care of it as best you can, and that's fine. But the fact of the matter is that the process that I showed you will work each time. It's just, do you want to be patient enough to do that? So the final answer here should be, you got u to the 14th du is going to be equal to 2 u to the 15th over 15 plus c. And substitute your u back in, and that'll be the correct answer. Raise your hand if you got it right. Good job. Okay, let's try a harder problem. Okay, what do you think I should choose u to be? That's the one out. So in integration techniques, a lot of times this is how you start out. And you got to try the problem 2, 3, 4 times before you finally get it to work. Sometimes an approach won't carry you to the end. It's just the way it is. So du is equal to what? Right? Save yourself a little bit of work. Just pull the negative 2/3 out front. So then you have the cosine of the square root of x over the square root of x dx. So as soon as you get confused, just pull your constants out front. Deal with them as they come. So that way we can just focus on this. All right? Now, do we have a dx? Yes. Do I have a 1 over the square root of x? 1 over the square root of x. So yes, that does match there. Do I have a 1 over 2? No. So what are you going to do? Multiply both sides by 2. I get 2 du is equal to 1 over the square root of x dx. So now I have that right there. And I have my dx. Have my cosine. And instead of square root of x, I will have u. I will substitute u right in for the square root of x. So I could write my new integral at this point. My new integral, I have a negative 2/3 out front times the integral cosine of I don't have to write it over anything, do I? I just have to replace the 1 over the square root of x dx with 2 du. You don't like the 2, so what do you do with it? Negative 4/3 integral of cosine of u du. Cosine of u du. Antiderivative of cosine? Sine. So we've got negative 4/3 sine of u, which is the square root of x, plus c. Integration techniques can be difficult. Again, I want to encourage you. You are seeing the easier ones right now. All right, 4 is a great example. You don't think we have enough time? Sometimes problems, it just takes a very, very small part to really make them extremely, extremely confusing. For example, we could just make one small change to number 3 and make it very confusing. Number 4, right now the way the problem stands would be very, very difficult for us to get through. And here's how I know. As I look at this problem, we have tangent squared. Forget about tangent squared. Let's just think about tangent. What's the derivative of tangent? Secant squared. Well, that's right there, so that's nice, isn't it? Do we know what the derivative of tangent squared is? That doesn't necessarily show up. Let's get rid of that squared piece. I don't think Mr. Gens intended on that at all. So this is a nice type of problem that still we can identify. And you can see that this is my inside part. Most often that's going to be u. Not all the time will that be u, but this is a good situation. So let's try this. We've got 4 plus the tangent of x is equal to u. What's the derivative of 4 plus tangent of x? 4 goes away, I get secant squared. Do I have a secant squared dx? Where is it? Right there. Do I have a 4 plus tangent of x? Yes, it's right here. So I can make my substitution relatively very easy. In fact, you know, your integration techniques might become good enough where you don't even really need to do any work. You can just identify it and do it. So, u to the third du. Again, it says du is that, so I can replace the entire part with du. And if I take the antiderivative, I get u to the fourth over 4 plus c. Substitute u back in, so 4 plus tangent of x to the fourth over 4 plus c. to sometimes save space, the book will just say what u is, and then it will just, give you that portion of the answer. And that's fine. You need to plug it back in. We got time for one more. Again, you could see had we had that squared, it would have been significantly more difficult. We couldn't do it. Not today. Okay, the integral of 3x over 1 minus x squared dx. Are you getting tired of seeing those constants? Then just do this. If you don't like the constant, get rid of it right away. 3 integral of x over square root of 1 minus x squared dx. Any guesses on what u should be? 1 minus x squared, okay? Not always. Not always. Not always. Okay, so du, negative 2x. Let's see, you have an x on top. You don't have a negative 2x. So what do I need to do? Divide by negative 2. And I get negative 1/2 du is equal to x dx. Do I have an x up top? Yep, I have my x. I have my dx. Those are accounted for right here. And then I have this piece right there. So I could set up a new integral. Yep, let's write the negative 3/2 out front because you got this negative 1/2. We'll just bring that out front. 1 over the square root of u. Are you okay with that step? Do you see how I got the negative 3/2? 3's out front, the negative 1/2 is right there. The x is taken care of, and the dx is taken care of by negative 1/2 du. Right? So then that just is 1 up there over the square root of, this thing was u. So I've got 1 over the square root of u. A lot of people struggle with the square root of u, so I'm going to rewrite this, negative 3 over 2 times the integral of u to the negative 1/2 du. What's the antiderivative of u to the negative 1/2? Good. 2 square roots of u plus c. That's the antiderivative. What happens to the 2's? You get negative 3 square root of 1 minus x squared plus c. That's your antiderivative. So I'm guessing that it's starting to sink in, but we need to practice this tomorrow, right? Okay. I'll have to, if you're not going to be here tomorrow, I'm going to have to come up with an assignment right now. So